can't really afford any further delay, obviously. So this is how it happened anyway. It's a historical problem. And so we've learned the lessons, and we don't want this sort of thing to keep happening again, and especially next week in this stage. Okay? And then the next theme, I would say, is our website, our project website, because we will sort of criticize about our commission officer that when they refer the initiative to their bosses and the high-rank officials in Europe, the European Commission, they don't really have the accredited project website, and our project officer even gave us demonstrated the other two collaboration projects, the same projects, and funded together with the same core. And one is with India, another with the Latin America, with Brazil. And their website are very, very impressive. Have you seen the website? Yes. Yeah. You mean those with? Yeah, those websites. The other two projects. And were you impressed? Yes, they are quite good. Yeah, and you can see that with a lot of photos, and that's why I feel more confident after this event, because we have got a lot of photos and the video footage as well, especially the Chinese media. Huge attention has been attracted, as you can see from what happened yesterday. So we should be able to do a better job than after the meeting. Yeah, good, excellent. And therefore we need to discuss a bit more about the website. Okay? And so that is basically the arrangement of what's going to happen today. And of course, I will invite our Switzerland partner to make a short presentation with you yourself, because at the negotiation meeting, they were not there, and therefore we just want to make sure that knows each other, and we build up a team and work together. And so, would you mind? Are you ready? You need to do a presentation first. Yeah. Okay. Good. So let's see. Make it about 10 minutes. Yeah? It's fine. Okay. So I will need the book talk. You have no slide. You guys don't have slides, that's fine. If you have slides, you put it here. Let me see. I'll just take this off. So, and then you别拿胶囊带这里的过去，在这里可以自己接的嘛。这它它现在是属于电源，就把它这个显示对线给打。不用拿这个。You can stay there. I just stay there. You can connect to the protector. 过去先弄。
思就是电池。
Switzerland. I took here some pictures since we plan to have a workshop or some project meeting there. It's a small city with about 40,000 to 50,000 inhabitants. It's located on a lake in the Italian-speaking part of Switzerland in the canton of Ticino. It's easily reachable. It's about 45 minutes from Milano by car, or 2 hours from Zurich by car. The train distances are slightly longer. Times are slightly longer. Lugano is also directly reachable by plane. There's a small airport next to Lugano. It's 10 minutes away, but you have to book flights for Zurich if you want to use that airport. Or you fly to Milano Malpensa, and from there you have frequent shuttle buses taking about 1 hour to come to the city center. Lugano is a popular tourist destination. It's one of the most popular ones in Switzerland. We have some pictures here from the right up down. The castles of the Zona that are part of UNESCO World Cultural Heritage. There's an old village next to the lake Morcote. There are many of these kind of villages. There's some astronomical observatory in top of Monte Generoso. There are many local wine music makers that can be visited. And it's also a good idea to make some boat trips on the lake of Lugano. So when we have a meeting in Lugano, there are plenty of choices for recreation activities. The University of Lugano is located about 10 minutes walk from the city center. You won't need any public transports, you won't need any car to move around in Lugano. Everything is walking distance. The university is relatively new. In '96, 3 faculties were founded: the Academy of Architecture, the Faculty of Economics, and the Faculty of Communication Sciences. And in 2004, our faculty, the Faculty of Informatics, was created. And in 2008, the Institute of Computational Science, Professor Pause is the director. Our faculty currently has 23 faculty members and additionally 5 adjunct professors. There are approximately 100 PhD students, and the faculty offers bachelor degrees and various master degrees with several specializations. So we come to a short overview about the working area of computational science.
Okay. So this is just, let's say, this is just the topic we are working on in my group, because there was a longer talk yesterday. I just put it like this. There's a lot of ongoing work in terms of discretization methods, finite elements, non-conforming finite element methods, finite differences. We are working on fast solvers for linear and nonlinear problems. This is multi-level methods, domain decomposition. Constraint minimization, convex, non-convex applications are mostly in mechanics, biomechanics, medicine, and there's also some fluid dynamics with structure interaction, multi-scale problems. So this is just a list of things we do at the institute itself. At the ICS, there's a little bit more of work. This is what I've been presenting yesterday shortly, and there's of course a web page you are shortly invited to have a look at. That's the idea, right? So we somehow try to close the circle between mathematics, informatics, application areas, and supercomputing. What you see here on the right-hand side, by the way, is not an aircraft. That's a piece of bone of the spine. So that's a study for surgery, and here you can see stresses. On the left-hand side, you see the model of the human heart we are using for electrophysiology. And just in terms of application areas, as I said, we are working in particular on fast solvers for coupled models, which I consider to be a challenge. There's high-performance computing mechanics, biomechanics, and also non-Swiss effects, surface effects, and mechanics as friction and contact. And what we try to do is not only to create a method, but also to create the corresponding software in order to be sure that at the end you get something usable which can be really exploited in real-world applications.
To give you a short overview of the work done in my group, so I'm assistant professor at the University of Lugano. I'm working with currently 1 postdoc and 4 PhD students. The work is focusing on dynamic program analysis, creating concrete analysis tools, and also performing various system optimizations. The main focus is on workloads written in managed languages, such as workloads running on top of the Java virtual machine, for example. It could be applications written in Java, applications written in Scala, and so on. Most of our tools are fully portable across all kinds of systems. Worthwhile mentioning is also the line of ongoing collaboration with the Shanghai Jiaotong University, and there's a special funding instrument in Switzerland providing dedicated budget for Swiss-Chinese collaboration. So that can also be used for establishing further collaborations here. There are several calls every year about having budget for collaboration with Chinese organizations. So one of the systems we created recently is called Diesel. Diesel is an aspect-oriented domain-specific language for bytecode instrumentation, and it features an open joint-point model, which means that any region that we want to instrument can be seen as a joint point in contrast to mainstream aspect-oriented programming languages. And Diesel allows you to have combine high productivity of tool development with flexibility and ease of use and optimized generation of code. Normally, if you create instrumentation tools, you work with low-level abstractions, resulting in quite high tool development effort. We can approximately reduce the costs to create new analysis tools by a factor of 10. At the same time, we have the full expressiveness as in the low-level frameworks, and in addition, we create code of quality as manually tuned, and this is also thanks to an integrated partial evaluator that's based on symbolic execution. There's also a dedicated framework for parallelization of small tasks, which is difficult because the communication overhead, passing this task from one thread to another one, often outweigh the benefits that can be gained from parallelization. So there's a transparent integration of buffers and buffer management and various buffer processing strategies that allow you to get good speed-ups in analysis, where actually the computation of the base program doesn't really depend on the outcome of the analysis. So it's good to being outsourced to otherwise available cores. This works well on multi-core machines if your base program being analyzed doesn't fully exploit all available cores. The work on Diesel has been presented at Modularity, AOSD, in code generation optimization, and there's also delivery tools, and it's been used already for some concrete tools, such as in an Uppsala paper or a paper on a symposium on memory management presented later this year in Beijing. Another topic my group is active on is on workload consolidation on multi-cores, and I think this is probably the topic most related to this project. The goal here is to predict performance and recurrence of workloads on the same multi-core machines. We follow a model-driven approach using a queuing network. There is no need for simulations or extensive experiments, so you basically specify some performance objectives and the kinds of workloads you would like to execute, and afterwards our predictor tells you which workloads to put on the same machine and how many instances you can put of these workloads, such that the given performance objectives, such as maximum response time, will not be violated. So usually you would like to have 80% resource utilization across all resources, homogeneously across CPU, memory, disk, network, and so on. And this can only be achieved by somehow matching complementary workloads and consolidating them on the same machines. And in our measurements, which were based on the IBM Power 7 machine, which has a NUMA architecture, We have an average prediction error of below 8% by two-class consolidations, so considering two kinds of workloads, and all benchmarks in the Takabu suite, which is a popular suite of Java benchmarks based on real-world applications. And this work is going to be presented at the General Systems and Networks conference and at the High Performance Parallel Distributed Computing conference this year. Finally, as the last part, I'm currently working also on scalable services. We worked on auto-tuning middleware for executing composite services and also on service replication and load balancing strategies, considering first private platforms, but recently also considering deployment in cloud platforms. And for example, we have some papers here in Principle and Practice of Private Programming and in SCC this year. Finally, how to get more deeply involved in this project, we suggest to organize a meeting or workshop at the University of Lugano to invite some Swiss experts to this meeting, focus on dissemination of research done in the area related to the project, and possible topics include, but are not limited to, computational science, multi-core optimizations, cloud computing, or domain-specific languages. Finished now the presentation. We can start the discussion.
Yeah, okay, yeah. Thank you. Any questions from our audience? Before we move on?
I have a question. In your presentation, you show your group developed a lot of software or tool. This software or tool is free or commercial?
So, Diesel is open source under the Apache license. There's a new version, it's called Diesel. This is not yet available, which reduces the measurement applications by outsourcing all analysis activities into a separate VM. Basically, creates a complete shadow of what's happening in the observed VM without minimal interference in that VM at the bytecode. This is not yet included in the release, but the basic Diesel as described in the papers is open source. But it would still benefit from some more documentation. But it's already been actively used by other groups, for example, in TU Darmstadt, also in Shanghai Jiaotong University. Workload consolidation on multi-cores is a collaboration with IBM Zurich, and I doubt that this is going to be open source. It has to be discussed, but so far it is not open source. And that work is currently not released, so we can make that available open source, it's no problem.
Okay. Any more questions? Okay. I'm not sure about my pronunciation of your Spanish name. I think it's Guillermo. Yeah, don't worry. I'm doing my best. The project, the description of work according to the documents, we are in work package 2, and this event is going to be a sort of the finished touch for work package 2, and which we will be expecting to produce a report about the introduction of the TFL1A system. So I asked Dr. Mother to prepare this document, which is deliverable D2.1, and also D2.2 is going to be a sort of published proceedings of our kickoff meeting, and therefore I would also try to liaise with that and organize something for it. And then you are the work package leader for work package 3, and which is the major event is going to be the meeting and or workshop or whatever we call it in November and next day. So I'm just wondering if you have any presentation and about your plan. Yes. For this work package 3 and the next meeting.
Well, we have made a presentation between Fermin, me, and Marco, and
okay, excellent. Yeah.
And we can go point by point.
Okay. Yeah. Then we will discuss how we organize the meeting.
Yes.
There are so yeah. Walter, can you pass on the date to Yeah. 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 And then after that, we go to the book, and the leader is our Bulgarian partner. Unfortunately, their research rejected, so we're not able to make it this time. And of course, hopefully, in the meeting in November, we will then have a discussion and a fixed date for the hosted meeting. And then we will pass it on to Professor Ron, and your turn to and that will be your package chart. But anyway, I think it would be good if you could persuade your steering committee and to combine the work package 5 and 6 so we can have your conference or whatever meeting in Tianjin University.
I will try.
And then that would be easier. Well, so I think that would be, we've got a good argument. We do try to do that.
Because, as I told you, there are problems because this year we've been in Taiwan. And some of the student members really wanted to be in Europe. Because we also got other projects that would have been among the big IT projects. So I have to try to convince them. And of course, they also rely on what kind of resource will be available from here, and then it's easier for me to convince them. China sees it as important. For example, the center here will be supportive, and this is we're machine. We have so many applications, things like that. We can try to present and persuade the steering committee.
Okay. Yeah. Otherwise, then you have to organize a meeting at your place.
No problem.
Oh,
You are all welcome.
it's up to you. Not today, not this time. You're a bit far away, and so you've got plenty of time to prepare. And even today we're going to focus on the Spanish meeting. Yeah. Are you ready?
Yes.
Okay. Yeah.
Okay. Well, first of all, I would like to explain that why we are 4 Spanish here in Tianjin. Well, actually not 4 Spanish, 1 Italian and 3 Spanish. As you know, most of you, Fermin and me, we belong to the University of Zaragoza, UNIZAR, to the BIFI, which is our university. And the thing is that in our institute there is a very strong physics group that collaborate very stretched with the group of Victor Martin and Marco Bailey. And as they will provide the first code that we are going to test on Tianjin, we thought it would be very interesting for them to be here with us in the meeting. Okay? So this is the outline of the slides I have prepared. First, I promise very short introduction just for the people that don't know about us. And then we will go into our contribution to the project. Okay? As you said, we are the leaders of the Work Package 3. And Victor and Marco will put into context the first code, the first application that we are going to would like to integrate to assess, to evaluate on Tianjin. Okay? Then I will talk about the other application that we are in charge of, which is Octopus. And then we can discuss about the workshop we held in Spain. And maybe we should start to discuss about the deliverable, which is the main outcome. I think we have to produce in the work package. Okay? And finally, as we have collaborated with some dissemination stuff like the website, the wiki, and maybe the logo, I don't know if you like it, all of you. I also prepared one slide to discuss about that. Okay? Well, just to introduce very fast our institute, BIFI stands for Institute for Biocomputation and Physics of Complex Systems. This is our structure of the research of the institute. Is grouped in 4 big micro areas. One is biochemistry and molecular and cellular biology, the other one is biophysics, the other one is physics, and the last one is computation. Fermi and me, we belong to the computation area, okay? And namely, I am the responsible of the high performance computing there, the group, okay? And the group spin glasses in there in the physics is the group that collaborates very strongly with the group of Victor, okay? And at the bottom you can see some stats about the funding, the number of people. Currently we are almost 200 people taking into account the the engineers, technical staff, senior researchers, and so on. And the other is about funding, okay? And there are two more slides about the main e-science and let's say HPC resources we host, because we are also let's say a supercomputing center. We are not as big as Tianjin National Supercomputing Center. We have more modest resources, but okay. Here is a summary. First, we run a node of the Spanish supercomputing network. You probably know Marinostrum in Barcelona Supercomputing Center. In the past, it was reached I think it was the 4th in the world and the 1st of Europe some years ago. And this is another node. Okay. So in total, currently we are 8 nodes in the whole Spain. Okay. And these are other important resources. We have another distributed memory cluster, Terminus. Well, those figures are not updated. That cluster now is over 1,000 cores. We also participate in European grid initiatives like EGI. There we the Spanish National Grid Initiative. And we have some important resources there like RGrid and PeerGrid. Okay? And recently we purchased a new shared memory system which has 3,000 cores and 12 terabytes. We also have some cloud resources. There is another research group which works in cloud computing, which currently is an emerging technology. We also run some services on long-term computing distributed memory approach. There is a very important project whose name is Iberfilis that in Spain and in the rest of Europe, and I would say that we have over 23,000 volunteers, okay, contributing and computing with their desktops and with their laptops, contributing to science, okay, for the researchers. And finally, we have special dedicated computers. One of them is Janus, that now Victor is going to introduce, that is very related with the spin glass model that we are going to work to evaluate here. Okay, so let's go inside the project. This is work package 3. The title, as you know, is Tianjin challenge with complex computing tasks. According to the description of work, the two main goals are first to adapt and optimize the selected codes. I think, well, there are 5 codes in the description of work that have to be run on TI. And then we should make a performance analysis and an evaluation of the results that we obtain running those applications and after adapting and optimizing them. Okay. So I brought this table which makes a summary of the applications. Each one corresponds to one task in the description of work, and those are the responsible partners. I have put in bold the partner I consider is the main responsible. Okay. So let's go first. First code, as he said, is a spin glass model, namely the Heisenberg spin glass model. And to speak about to give the current status of the application and the schedule, we have decided together, Victor and Marco. Okay, I'm going to contribute to the talk.
Okay, so I'll be very short about that, just to put the things in context. You probably know about spin glasses. Those are maybe the simplest model system that detects a very complex dynamics. Their study has been influential for computer science, as it gives very deep insights into non-polynomial complexity, non-optimization theory, the financial market, and so many complex behavior models. But we are mainly interested in physics as a model for the glass transition, and Marco will tell a little bit about that. It is one of the hardest problems in theoretical and computational physics, in spite of the simplicity of the models. And they basically came in two flavors. We have floating point models, and in this respect, I would say that current day resources are simply not up to the task. So we are really seeking some new efficient solution, and we hope that the GPUs could be a good possibility. But you can also study models that you can stress in terms of discrete degrees of freedom, such as integers. And in this respect, we have some very new and extremely successful solution, which is basically doing our own hardware, which is the Janus computer. So just to be very brief, the Janus collaboration is a collaboration formed by a team of physicists and engineers in 5 universities in Spain and Italy, which is the Spanish nodes are the Complutense de Madrid, and Zaragoza, and Extremadura, and we also have a very strong collaboration with La Sapienza in Rome and Ferrari. Janus is a FPGA machine. We have a fair number of machines of FPGA, 56, and just to give a brief idea of how it works, this is a figure of merit of how things are. I'm putting here, these are our time in logarithmic scale, so the typical experimental time, the relevant experimental time for experiments in spin glasses is in the range from 1 second to 1 hour, I would say, and a standard computing solution can simulate about 1 microsecond. So there are some 6 orders of magnitude here. And Janus has basically halved this gap. So you're doing better than conventional computing by some 4 orders of magnitude. And this is the sort of a speed up that we are hoping to reach with the GPUs. Okay. Marco will talk.
Okay. Let me give you a more intuitive idea of what the spin glass is. If we look at a liquid with a microscope, what we see is many particles are all disordered that move all around for thermal fluctuation. If we look at a crystal, what we see is that the particles have an ordered structure and are still in their positions. A glass is an intermediate phase between the two, because if we look at it with a microscope, we see that all the particles have a disordered structure, but the particles are still in their position. A similar thing happens with magnetic models. We have the analog of the liquid, that is the paramagnet, where we have all the spins that point in random directions, and they move for thermal agitation. The analog of a crystal is the ferromagnet, where you have all the spins that point in the same direction and are still in that position. And then we have the glassy phase of magnetic materials, that is the spin glass. And here we have an analogy with the glass. We have all the spins that are still but pointing at random directions. The spin glass model we will analyze is, we will simulate, is a cube, a cubic lattice with a side that has up to 64 lattice spacings, and in which we have periodic boundary conditions and first neighbor interactions. The interactions between one side and the other are different if you take 2 separate experimental samples. They are the same only in average. This means that if we get spin 1 and spin 2 in 2 different samples of the same material, they could have a coupling that wants to align them in one case or disalign them in another case. The important thing is that in average the couplings have the same characteristics. So we call sample a different realization of the coupling, and we call 2 different replicas are two systems that have the same couplings but different configurations and maybe different temperatures. An important feature of spin glasses is frustration. It means that it is impossible to satisfy all the local constraints simultaneously. We can understand what this means in this drawing. The pluses means that the coupling wants to align the two spins, while the minus means that it wants them disaligned. In this case, the black spins will obviously want to be aligned because they have pluses between them. But then when we go to the fourth spin, it wants to be aligned with this one and disaligned with the other one. So there is no optimal solution to this. And this is intuitively, it's why the spin glass dynamics are so slow, since the system keeps traveling along all the configurations without finding an easy optimal one. The particular spin glass model we are simulating has anisotropy. In fact, it's the anisotropic spin glass model. That means that we have no rotational invariance. I give a brief formal definition of the model. The spins are modelized with unitary three-dimensional vectors. And the energy I stress again that is made of only local terms. The interactions are of only first neighbors. So we can write it this way, with each spin interacting with a local field. The local field is made of three terms. A global field that is the same for all the spins. An isotropic coupling, Jij, that is a scalar. And an anisotropic coupling that is given by the matrix D, and that is a 3×3 symmetric matrix. The J's and the D's are random binary parameters. So this means that we can, to define a symmetrical 3×3 matrix, we need only 6 values plus 1 for the J. We need 7 bits to store them, so we can put them in 1 byte. And this helps a lot optimizing the memory access in the GPUs. Now, how do we simulate the dynamics? It is impossible to visit all the states to calculate averages because there are too many. So what we do is Monte Carlo sampling. That is an important sampling. Principally, we do not sample all the space of states, but we just visit we sample some parts of it according to their equilibrium probability. We are using 3 main updating routines. The heat bath, that is exactly the definition of what I just said. It proposes a spin flip according to its probability. Then we have over relaxation, that is a faster updating algorithm that is deterministic and maintains the energy constant. This obviously it's not physical, but it is physical if we combine it with heat bath. And it makes the simulation much faster. As a final point, we have parallel tempering, that is an algorithm that gives us the possibility to not get stuck in local values of the energy. And it consists in once in a while, exchanging the temperature between 2 different configurations. I stress that this is not it's not an embarrassingly parallel problem, because embarrassingly problem means that running each sample independently. This is what we do, but within the same sample, it is not enough. This drawing shows the relaxation times with temperatures. What we want to do is to reach low temperatures. And if we look at the relaxation times, they increase very steeply. So it's we need very strong. We need to be able to simulate very long times to achieve good measures of low temperatures. So that's why within the single sample, we also have to invent tricks to speed up everything, and we need good computing resources. We have 3 levels of parallelization. One is embarrassingly parallel. Each sample is run independently. Then we have a coarse-grained level of parallelization that is given from parallel tempering. I say again in what it consists. We run many replicas of the same sample, each at a different temperature. And then, after many iterations, we switch the temperatures. This is a very effective type of parallelization because it only requires the exchange of one floating point number. So this is the second type of parallelization we use. And then we have a third level of parallelization, more fine-grained, given by the fact that we have nearest neighbor interactions. So if we look at this drawing, the red planes are completely independent between them, and so are the black planes. So we can update all the red planes simultaneously and all the black planes simultaneously. And this is what we do. So I give some benchmarks of the program. We are on an L equals 64 lattice. That's the greatest lattice size that we are using. And it takes about 500 clock cycles to do an over-relaxation spin update. I give the data for an over-relaxation because it's the one we mostly use during the simulation. And this gives, if we calculate the updating time in a Tesla M2090 GPU, we have, that is the one we have access to in Barcelona. We have an update time of 0.77 nanoseconds. When we go to realize our benchmark with a real simulation, we get 2.3 nanoseconds. That's 30% of effectiveness due to the memory rewrite overhead. And if we multiply this number, this time by the total number of iterations we need to thermalize the sample, a single simulation takes about 2 weeks. So, concluding the part of the program before leaving the word to Guillermo once again, what we present is a program that is actually running in the Barcelona Supercomputing Center in a small cluster of 250 GPUs. So the program we have is stable and it could be already be used to do some portability tests and benchmarking on Tianjin. I showed how the problem of time is an intrinsic problem of the physical system we want to simulate. And it's a simulation would take from 12 days to 1 month of continuous simulation. We have one more level of enhancement of the program that we did not put in ACT. And it would be parallelizing between all the replicas of the sample, running one replica in each GPU. We did not do that because in Barcelona it's impossible, since it would be running in 100 devices of 256. It would be taking all the center for us, and they wouldn't let us. And also, if they let us, we would have to wait to have 100 free GPUs before the job can be launched. So it's impossible there, but in a big size center, we see it more feasible. Plus, the parallel tempering only requires the exchange of one float. So this means this is very few information to be exchanged, and it's only once every big amount of steps. So we would have a very little overhead due to the information exchange between one GPU and the other. I'd say this is more a parallel problem. Like the parallel tempering is a parallel problem, as Professor Proud was saying yesterday, while the parallelization within the same replica, the division in planes, that's more a parallelization. So the speed up with this method would be ideally of a factor 100, that's the number of replicas, and it would be reduce a 1 month simulation to only 8 hours. And it could make us think to study a double-side lattice, so we could get to 128. And we know that the bigger the lattice is, the more representative the results are. And I stress also that we could easily saturate Tianjin with about 100 independent L64 samples. And we could saturate it all since, yes?
Lattice, there is physical lattice type respond to your lattice.
I'm sorry?
I know in the physics, we do the simulation with the lattice model. Every lattice
how much it is?
Between two lattices.
It is much less than the experimental size. It's like 0.1 nanometer.
No. In right?
Yes.
Oh.
Oh well, so I think we're done. We could, I was just saying that since we can run many different samples, we could saturate the computer, the supercomputer by running a different.
What do you mean exactly by saturate?
Like use all the GPUs.
All the GPUs.
Yes.
Right.
Because since we need thousands of samples, we just if we have 3 nodes, we just run no samples.
Right. So you mean to the full capacity of the.
Yes, we could use the full capacity. With obviously it wouldn't be all coarse or fine grained. There would be a mercenary parallel part, but we could fill it all.
Okay.
Now I leave the word to Bijan. I don't know if anyone wants any questions now, or we could refer to them later.
Any more questions about the scientific computing? I think it's very good to be a scientific computing task. Yeah, we'll discuss it later.
So regarding the task 3.2, it's corresponding to the Octopus toolkit. By the way, I think yesterday this application has run already in the challenge.
It's one of the big challenge ones.
Yeah, I saw yesterday. It's contributed by, well, this software has been developed, I think, in the framework of another European research project. And one of the developers is based at PIFI, is a senior researcher, Alberto Castro. He collaborates with the group of Angel Rubio in Basque Country University. Okay? And this is a software for the calculation of electronic properties. So we have been talking to them in the last months, and we make this schedule together as this person will be the main user that will make the migration and adaptation to Tianjin. And so we established this schedule. First stage, that is the stage that we are currently at, is to port the code to the GPU resources that we run at PIFI. We have in our data center some servers, just 2 of them, plenty of GPUs. One is Tesla and NVIDIA Tesla 2050, which is I think exactly the same you have here in Tianjin. And the other one are Quadro GPA 570. Currently we are at that stage, but they are going on, and probably in a few weeks we will have a first version running there. Then we will make a performance analysis that they will compare with this previously have ported this, well, similar code to another GPU infrastructure, and they will make a comparison. Okay? And then we are ready. After that, we will be ready to be adapt this software to be run on Tianjin. Okay. The last point is to make the assessment, to contribute to the deliverable, to make the performance analysis. They want to make they are very experts really optimizing. This group is very expert optimizing applications, and they want to fine-tune all the parameters to. For them, they said that the most important, the key objective is to find the best ratio between GPU, CPU use when doing hybrid parallelization, NPI and OpenMP. Okay. So, so far I think one thing we can discuss, I don't know if we can do it now or this afternoon, should be to establish the procedure to access your system. We have to discuss, okay? I don't know if, I think we have to decide if you will give us an account, I mean, or users will directly log in from Europe to Tianjin, or you will execute on our behalf, okay? This is something we have to discuss. I suppose we can do this afternoon. We also should know how many resources will you offer. I mean, we will be able to, as Marco said, to saturate, to use the full capacity of GPUs and CPUs of your system. For how long, how many CPU hours you are willing to offer, okay? And finally, it would be very nice if at this point, as you see, there are, well, the application of Marco and Victor is really to be running, to be adapted to migrate to Tianjin. So it will be very nice if you can give us a pointer or directly on your documentation. I don't know if you have an English version or you can make a brief translation, okay, with the getting started manual. And we would like also probably to know the level of support that you are going to offer us. I don't know how you are organized, if you have a support team that we can write to them, even phone them, okay? So I think this should be discussed, okay? Okay, then I have prepared this slide to discuss about the workshop, which is the last task of the work package. As we decided in Brussels on the negotiation meeting, it should be an international workshop about GPU computing. We haven't decided yet the title of the workshop. I think it would be something generic like International Workshop on GPU Programming for Scientific Applications or something like that. Okay? We can discuss this. It will be held in our city in Zaragoza, probably in our premises in the University of Zaragoza. And what I think is already confirmed is the dates. If you remember when we made the video conference, I think it was 5th March, I gave you some provisional dates, but you said, no, we have to move some. We were assuming that suggested because the week before is the Supercomputing event in the US, in the States. And then after that, I think they had you had another event that collided that. So we decided to move 2 days in advance. So in principle, 26 and 27 November. Okay, I think it's a Monday and Tuesday, but probably it's not the best days. But I would prefer in the middle of the week. But it's no problem. Okay. So I communicated these dates to our colleagues from Barcelona because. We will co-organize with them in the framework of the Spanish Supercomputing Network, and they said, perfect, go ahead. And very probably, okay, this is another thing we should discuss about the configuration. I mean, the agenda, what kind of speakers we invite. If you remember, Jamin, when we were in Brussels, yes. Panos, our project officer, he said to me, before configuring agenda, I will send you a guest list you should invite regarding this field of GPU, okay? But I think I will contact him, okay, after this meeting. And we also, of course, it would be fantastic that someone from here, from Tianjin, come to Zaragoza to make a presentation. I think that will attract the media, because if we make a person, the second, the leaders of the supercomputation in China are in Zaragoza, it will attract local media. Okay, this is very important. So it would be very nice if any of you can come to Zaragoza. And
just confirm that Director Liu will be there.
Fantastic.
You himself will go there. Okay. And I think it's the best possible support.
Yes.
And he also said that he would make a Channel 1 available to our project, to our consortium. And our partners specializing in scientific computing, like our Swiss partner and the Spanish partner, and maybe our advisory group as well, and to use Tianjin 1A and use your scientific computing tasks. And so the details will be discussed later on about the programming software or interfacing or whatever we found. Okay, nice, that's good. And so can I just ask the Director Liu would like to say something, and I will translate for him, and that will be good. Okay? Before we start the next discussion.
Welcome to the message. All the message that is open letter forms. Welcome to the use the device computer.
Yeah, I'll translate.
想讲三个问题，第一个呢，就是说像三个层面上，第一个呢，我觉得呢，我这个项目已经受到了中国政府和各个媒体昨天的这个维持的安全大家非常高度关注。
And he will speak about the three points. He will make 3 points. And the first point is that the organizing this event is SCC-Computing is very important, not just only for the project, but also for the Supercomputing Center. And it attracted huge attention from the Chinese media, as you can see from yesterday. And many people, as journalists, came in and broadcasted the news and the activities about this project.
我们中心也希望通过这么一个 project， 然后呢，首先大家就是说，他们对内的一些俄罗斯啊、academic 啊这些研究单位，开展就是基于天河的高精计算的这些技术项目合作。
这个 sorry, it's difficult to switch on from the Chinese and the English, but anyway, and Dr. Liu wished to say is he would like to make the Supercomputing Center, especially the KM1A, available for all our European colleagues, and welcome all the academics, industrial companies, and whatever scientific computing tasks or applications you have, and you're welcome to come to use the KM1A, and with a very small cost. It would be cheaper than using your local supercomputer center and all facilities. But this is again negotiable.
我想3个层面我们可以做到讨论一下。第一个呢，就是说，因为大家欢迎大家就是说使用天河来从事你们的这种科学计算，包括各个方面的。这个呢，我们给你们开个账号，你们通过在你们大学在你们单位远程的通过网络就可以使用了。 现在实际上，我们已经也在香港的，包括现在还有South Korea， 另外 America 的 Hollywood 这样一个 film 的 production 这样的一些优势都在提供服务。
There were 3 levels of possible service will be provided by the Supercomputing Center, and the first level would be they can establish a remote connection and establish a specific account with each of you if you have scientific computing tasks or any applications, and that will enable you to access the KM1A remotely. And this service has been proved very successful, and with many other application companies, including well-known companies as well as the Hollywood field makers.
新天1号1年多，1 years。 以我的特殊问题，就这5个小册子里面，这些应用领域，我们都有相应的用户。
And a little more than 1 year, KM1 has been up and running, and within this past 1.5 year time, the KM1A has been applied successfully, accessed by more than 300 users, and all the areas covered in your leaflets actually included in all the applications. All the existing applications have already covered all the areas. So they have very mature service provision facilities, and to enable all our European collaborators to use KM1A.
因为我觉得the second level 的 cooperation 就是加入起来的合作，我们可以去一起安利的推举的 program， 就是说我们可以共享我们用户的这些技术，提升我们这部分应用的这些这种水平。
你是说这个合作对象 the Supercomputing Center has a very professional team of software engineers, and who will be able to help you to optimize your source code of your program. And also you will welcome the collaborations in developing the new application programs, optimizing the source code, and make sure that your data, your program, everything will be secure.
第三个方面就是利用共同的这种利用软件和我们的经验，就是为 industrial 的 user 去提供服务。
And the third level of the service would be the existing, proved successful application software and professional teams, and co-developed with their collaborators in China, and which ranges from the big petrol companies, life science, pharmaceutical companies, and the media, digital entertainment companies. So almost every area, and they have co-developed a lot of interfacing software and service software with them. And all this co-developed software will also be open to our European collaborators.
就像那个 medical 的 factory， 就是这个做生物药企啊，有很多美国、欧洲的，就是通过与华大基因合作做样本测试，然后在我们这做计算。所以从这个安全性和保密性来讲，我们是能满足完全的满足要求的。从性能上讲，肯定是我们有很好的计算能力，肯定也能满足他们的基本要求。
One very good example is there are many users, companies in America and Europe already in collaboration with a Chinese pharmaceutical gene life science company. I don't know what the exact English name, but it's called Huana Gene. BGI. Okay, it's BGI. It's a very big, well-known Chinese life science gene company. They have collaboration with the many organizations around Europe and America, and therefore they have already co-developed a lot of the scientific computing software. And basically, the American, the European companies just use the BGI, BGI to test all the samples and do the pharmaceutical testings. And then scientific computing, the side will be initiated from this BGI, the Chinese company, and handed over to the Supercomputing Center. And K1A will do all the scientific computing for them through this Chinese company, the BGI. And therefore, the security and privacy and data and maintenance is all up to the highest possible standard.
BGA 实际上什么时候是德国建立的那个 KoM 大肠杆菌做基因测序。
Okay, BGI is a company who a long time ago collaborated with a German company, life science pharmaceutical. KoM.
大肠杆菌，就是在大肠出血那个。
Does it ring any bell to you? A big German company. KoM.
因为没有大肠杆菌的，不是大肠出血吗
CO something.
全世界一个新闻，就是因为那个。
Okay, but anyway, it's a German life science company collaborating with Tianjin Supercomputing Center. With
最终一个我们希望就是我们共同合作，不断的推动中国和欧盟在高端计算机技术上不断进步。
So finally, he wishes to cooperate with European researchers and scientists and to develop further the high-performance computer area as well as technologies. Okay, thank you. Right? So we just do a round of applause. Okay. And is there any questions for directly you? And you have one.
Yeah, I mean, I can just speak English and.
Yeah, no problem. No, you speak English straight away.
Okay. Yeah. So this, for example, the specification of the Tianjin and especially the operating system, how it works. those materials will be available for us? Yeah, when you say it's open, because you have your special format and also file system, everything. But we haven't get it yet. 操作系统啊，还有那些它后面的文件系统啊，那些的都是我知道，但是我们没有这个信息。昨天都有辅导。
Yesterday,
就是你想知道说这个版本啊，
对吧？
啊，你可以参加 website 上面，就是说那我们生成的 website 上面的information.
Now we also have the handbook of users.
So you have a handbook.
Yeah.
Available for us.
We finished the English version, and
I can get a Chinese version.
Are you finished?
Okay.
yeah.
Okay. So there will be a handbook for Table 1A, and which will be it's already translated in English, and so it will be handed over to all of you. So you are able to prepare your software when you use access to Table 1A, and you will know what sort of system, specification, configuration, and all the technical details. So you will be able to prepare your scientific computing as well as your programming. Okay.
现在这些软件都是国际标准的相似建营的，很多用户的那个把详细的建营的这一开始也是没去。
三分钟叫拿过来去总编，还是没有去。
基本也就是主要是 level 有差异，但是不是太有。All the written software is based on the information standard. Shanghai, OS.
So if you can get the slides from yesterday of the rules presentation, maybe the handbook. The second question is if the company.
Okay, well, let me just translate first what directly you said. And all the maintenance software, interface software around the Table 1A and enabling your access to Table 1A, they all according to the developer, according to the international standards. So everything is pretty much international standards. And therefore all the existing clients, including those from America and Europe, they all have access to Table 1A through this international standard software. And so it's quite easy and convenient to access.
Through the fusion, and development from the Unipatch tool, also the electricity to become login table and use the system. It's a general system and general environment.
Okay, we will discuss details about the Part 3, the execution of those tasks, and perhaps we will see what is the best way for you all to access the Table 1A with your program, and maybe we establish a specifically access or whatever account.
We will discuss this afternoon.
Yeah, we'll discuss it today. Yeah.
Okay.
Yeah. Okay. And also you will have the handbook, so you know all the technical details and the specifications, configurations. Yeah?
Okay.
Okay. Good.
One question?
Yes.
The 3-day training, is it like, where does it stand in this item? Yesterday we talked about the 3-day training to run programs in the China.
The professor from Peking University. They training their software.
Yeah, because 3-day training, what they talked about was yesterday was another professor from the University of Peking, and they said about their work, their scientific computing task, which requires 3-day training.
Okay.
Yeah, that's
So,
what we do.
it's not. It's unrelated to the. Okay.
No, nothing to do with this.
Okay.
They just presented their work, their application.
I want to be sure of that.
Yeah, no problem. Okay. No more questions?
So how would you charge those companies? The price range?
Within the consortium, Dr. Liu is happy to provide free access. Okay? Yeah, this is very supportive and for us. So, and what he would hope is that in return, that you guys could promote 1A with your colleagues and the national organizations, and hopefully would promote Tier 1A to such an extent that more customers would come to Tier 1A, use Tier 1A, and pay small charges to maintenance charge to help cover the cost. But for scientific computing tasks within the project, within our consortium, it's going to be free. Okay? Any more questions? No, if no more questions, let's just finally have another round of applause and to thank Dr. Liu. Right. Okay. Then we would perhaps before we move on to the next item, perhaps we need to finalize the details of these the scientific computing tasks and access to the 1A tasks. And so you from what you just presented, it seems that your spin model and all this software is ready. The program is ready.
The program is ready. They have a version that already have running Minotauro, which is a system of
yes, and you've run your program on the computers in the Barcelona Supercomputing Center, so you know the sort of figures and which can be used to carry out the comparative studies. Yeah.
Yeah.
Okay. Good. What sort of process you would expect to follow in order to access Table 1A?
Marco and Victor, Marco will be the end user.
We would you be happy to hand over your program to Dr. Monk and discuss the further details?
Yeah.
And to access how the Table 1A is to be accessed?
Yes.
Yeah. Maybe later on?
Yes, sure.
Yeah.
You mean later we will discuss the details how to access the
Yeah, I'll to access the Table 1A.
No problem. Yes.
And you carry out the tests with your programs.
Yes.
Yeah. Okay. Right. So can you just put it back and this slide on the about the meeting? Okay. Dr. Madden, just ask around if anybody wants to have a break. A tea break? It's up to us. Maybe you have 10 minutes break, a 5 minutes break. The coffee is available.
También toda la gente así, amigable, me dice, no me enseñas el código.
Internet partners are in the south of France, Zaragoza is in the north of Spain, so we are very close. It's like 6 hour drive. But we put a range, if you want to be a good opportunity, that visit to go on that meeting is
principalmente no es.
I've been 3 times there, you know. It's kind of interesting. They are building up huge.
No, es la pregunta. No, sí, sí.
几倍学到。
The beer I got was where we drank for hours. It was where I got the switch was getting from beer for like 4 hours. Totally.
apply for an account. Perfect. Okay, perfect. Nice. It's like it's the same procedure. Okay. Well, last question then. So we will have access to the system, and which policy, I mean, we will be able to use the core material. I understand that we will be in competition with the other users of the system, but you will apply some restrictions. I mean, we will be able to use up to a number of cores and GPUs. And the second question, for how long? I mean, we will have a window of 1 month or 2 months. We will be able to access the system until we finish the evaluation. As you run your page, you mean you have a price in advance per CPU model, right?
Okay, so we just get back.
Go ahead. Okay? Thanks all. A ver, la cosa es que ellos venden, entonces me está diciendo que también se cobran por lo que les permite.
Okay, can we get ready to carry on with our meeting? Demo, can you right. So the dates will be 26, 27, and that's fine with all your sites.
Yes.
Including the supercomputing network.
Yes. We already have booked the conference space.
Okay.
In advance.
That's good. How about our partners? Any is it okay? The base fine with all our partners? Yeah. Okay. Bern, are you able to?
I'm not sure I personally can make it, but I would certainly be able to send someone from my team who is actually expert in GPU. I think it would be more helpful. But I will make sure someone will attend from my side.
Yeah, I would hope to see you again.
I have to see it. November I'm always very busy, but
very busy.
Yeah, but currently my schedule is open. I blocked it.
Right. Okay. Okay, that's good. So we fixed the dates, 26 and 27. And is it Monday and Tuesday?
I think so.
Yeah.
Monday, Tuesday. Okay. Well, that's perfect. So we all arrive on the weekend.
Well, maybe for the Chinese partners it's good because of the jet lag. They can travel to stay during the weekend and then on Monday they are.
Yeah, I think that's good. Yes. And then we let's see the actions. Yes. What is your suggestion about the agenda?
Okay. About the agenda, you have to. Well, first, as I told you, Panos, our project officer in Brussels, said to me, before configuring the agenda of this meeting, you have to ask me, and I will give you suggested guests. So that's the first thing we will do.
Okay, can I just interrupt? Because Hannes, you got to be careful. I mean, you give him well in advance notice, okay? Because like this meeting, he said, no, don't fix the date, and wait for me. And because the commission needs to discuss how to organize the meeting and how to maximize the opportunities. And then delay, and then all of a sudden we said, oh, we're not able to make it. So please do make sure that this kind of thing.
No, in this case, I think I have established that deadline. Before 15th June, we should have a more or less provisional agenda. Maybe not all the speakers confirmed, but at least some the more representative for a general idea of the contents. And also to have under the project website a page for with information of the event and a page for online registration. Okay. Another suggestion, another idea, talking with our colleagues from Barcelona, we think it would be very interesting during put some sessions in the end of days for giving a training on GPU programming for scientific applications. And they have people that are quite expert, as they are CUDA, Excellence Center, and I was talking to Bernd in SETI Girona, and they are preparing a similar training day in, well, I think it was 2 or 3 days in Barcelona for this summer. So he said to me, no problem, we can reduce a little bit, and during the afternoon, we can send someone there to give the training. I think, at least in Spain, this kind of knowledge is now becoming very interesting for people. There are many people interested about GPU computing.
Yes.
Within the research field. What do you think about this idea?
Yeah, I think this is very good.
So during the mornings, we have speakers. We have chosen a colleague agreed with our project officer, and then in the afternoon maybe 2-3 hours of days to have a optional, I would say, training session about CUDA, OpenCL for these technologies for the GPU program. I think this will attract many people.
Yes.
They are in our center. We have a computer room with 40 computers, but there are 80 seats. So we should limit the number to 40 or even 2 people per computer. Maybe it's not suitable. Well, we will think on it. Okay? Depending on the number of registrants, we can move to another bigger place close to us. 2 hours. Okay.
Okay. Yeah, that's very good. Yeah. Yes. Then I would suppose I think it would be very useful to have a web page.
Yeah.
And on our project website.
Before
specifically dedicated to this meetings, and have an online registration and also some promotional stuff, and also to enable people to know what's available on provisional agenda maybe.
Yes.
And that would be helpful.
That's our idea. Yeah.
Okay, that's good. And any comments from colleagues around the table? Maybe, are you planning to have some sort of call for papers?
Sorry?
Call for papers.
If we make a call for papers, then we have to open the, I mean, we cannot choose at least all the speakers, right? So we have to decide. If you want, we can do it, but that means more effort.
Yes,
I think we are going to organize a workshop last year at the CloudCon in Taipei.
So a special session, a special track.
The one you mentioned in Athens, I think it was Athens.
Last year was a
workshop.
we had a workshop last year.
already.
You have
There's going to be a special track.
But the project didn't start. But this year we will continue. We already have a special session on HPC and cloud, but we can probably make another workshop just for SCC-Computing.
If there is such need indicated.
Yeah.
If not, then we'll just there is a special track.
Especially if we really want to target the next year to come to Tianjin for that. So we should consider. So the paper I suggest to submit to the SCC-KoM and
let me see the work package 4. In the work package 3, we don't have any procedures to publish. But the deliverable is the next one is the D4.1. It's the work package 4. We need to have the workshop conference procedures published.
The
So
workshop or just proceedings?
It's conference procedures.
Conference.
It
So it doesn't have to be a workshop.
According to the DOW. I think you already looked up before we
5.
Look at 5. Okay, then in that case, then it has to be our partner. So Gary will partner. Yes, okay. This work up to 4. So, yeah, it's up to you. We don't need to
I think it only says assessment, it should include the assessment results and the forum discussion report.
Yeah.
I think we can avoid so much effort.
Yeah,
The way we should.
we don't need that.
Maybe I can ask Panos what he thinks.
No, I don't think we will be, because in our DOW we not have any sort of deliverable regarding the proceedings. So in that case, we should not do that. Don't make any additional commitments. Okay.
We should include just a summary of the meeting,
Yeah, you could produce a report.
Yes.
And probably to be included or in the either P3.1 or to put out on the project website.
Okay.
Yeah. Okay. Yeah, that would be easier. So let's say the guest list, speaker list will be decided by panels.
Yes.
But I think we should do something as well, don't we? Panels will just recommend the
Yes.
GPU.
He said to me that he will send me a proposal. People that we should invite from the European community experts in GPU. I think that there are other funded projects around GPU in the last course.
Yes.
And of course, we should have time for people that have migrated and run the applications in Tianjin as part of the project. I mean, the other tasks before from 3.1 to 3.5. And well, we have users of GPU systems there in Spain, but of course, I think as we did for this meeting, each party could suggest people related to this field. to be invited to the workshop.
Okay.
To give a speech.
So apart from the recommendation from the panels, and should we have anybody in mind, or should we have the any topic?
You mean to
invite some speakers to the meetings, or
we were talking before, like for instance, people from ITER, nuclear fusion simulation, we are very close with the ITER responsible, and I think we could be involved in this kind of initiative.
Okay.
Also, other projects like specific gateways developed for other cloud resources would be easy. Yeah, like I said.
Okay, but I think we should restrict to GPU.
Yeah, definitely. Yeah.
How we are about to develop the GPU version user engine code.
Yeah.
If the according to the DAO, it seems to be it's not just GPU in the meeting. It's called the Supercomputing Challenges and the Research Forum. Yeah, not limited to GPU.
Well, it's open, but when we were in Brussels, I'm sure that I remember the conversation with Panos, and we agreed to make a specialized workshop, since the idea is a big system with graphic accelerators, to make a workshop around it. Okay, we can be open.
Yeah, okay, we could include the supercomputing challenges and these sort of things. Yes. We need to identify the challenges. We need to identify the needs of the SPCs developed is going to the next 10, 15 years. Okay. And also we need to work out a sort of research roadmap and make our suggestions or make our contributions to influence the horizon 2020. Okay. And all these things. And we also need to remember our major task of this project is to identify the common needs, mutual interests between Europe and China. So that is our mission, really.
We will include in the call for papers, the text for the promotion of the event. We can add several topics, including.
Yes, I think that's important to do that, because if we're not, as I presented yesterday on behalf of Panos, and Panos specifically added one slide and specified the role of this project. I feel a bit worried that we need to make sure we do deliver. Okay. Good. Any more comments around the table for this meeting? And we focus on what topic we're going to achieve through this meeting. We're not just simply going to Spain and have nice food. I'm sure you will like nice food. That's what we already have in but I think the more important thing is to make sure that we do achieve something, make some progress towards the final goal of this project.
We had some conversation regarding this kickoff meeting about some potential interactive visualization of real-time simulations. Maybe we could think again instance, running some kind of code here and
yes,
visualization for the media, for the people in Spain watching real time what is going on in China. This kind of things is an added value for the scientific and so that it's a way of increase the impact.
Such an demonstration, I would say.
Yes, and also one other possibility is that by that time, I'm sure you will have done some testing to how one made it.
Yeah.
And then you could put something up for open for discussion according to the testing results and your initial assessment. Maybe that sort of things could be inspired or prompt to be put on the table to discuss. Maybe that could be, I don't know. But another possibility is that when you invite the speakers and could request them to prepare a sort of paper, a survey paper, to help us to identify the research direction of those things.
Maybe we can make our own table with different people and make kind of a debate there. I don't know.
I mean, panel discussions.
Yes, panel discussion.
Yeah, but well, we tried yesterday, and but the outreach presentation seems to be what is to be required. Not much activities going on. I don't know whether that kind of panel discussion would be effective. So I think one possibility is that we draft some topics and request the keynote speakers and to prepare their presentation, because we've got a lot of time, not in advance, not like this one. This one we're really hasty. But the next one, we've got plenty of time, and we should be able to ask the invited guests to prepare something, and they can carefully look at the topics.
Okay. So you mean apart from the presentations, to make some kind of form or template, they should.
Yeah, something like just like writing a paper, and just to talk about what you think in the next 10 years in the area of HPC, where is the supercomputing goes for, and it's going to be the green power computing or whatever. I know the National Supercomputing Center, they are doing research on the low power consumption, and they try to achieve number one in the green power of the factories, top 500, and that sort of thing. But anyway, we could carefully drop some topics or questions and ask them to prepare the presentations. I think that would be good. Because at the end of the day, we need to deliver our project. Yeah? Okay. Okay, good. So, yeah, can I just put down, make sure that you jot down the two actions. We need to have an action list. Two actions. One is to contact Amos, and I will contact him as well, and you will contact him, and to ask for the recommended guest list. And we need that as soon as possible, and the sooner the better, because we need a lot of time to prepare all the things. And the second action is to prepare the web pages for this meeting.
We have 1 month and a half, I think.
Yeah.
It's enough.
But don't underestimate. I think it's lot of efforts is needed, and especially specifically the magic gas, because they have got a busy agenda. Yeah. Right. If there's no more comments, we'll move on to the next item, and then we will comment about this meeting. Yeah.
Are we going to package 5 later?
Yeah, if we want to look at package 5, then we can see.
Maybe I have one more.
Yeah, because, no, just because, because in the package 5 is set also assign on European seminar on cloud applications and computing in China. Yeah, so since we are going to Spain, maybe that workshop should be in Spain instead.
Is that intended?
I don't know, November this year, so we couldn't travel twice, right?
No. The Tianjin is the last one, the music meeting. It's next year.
Yeah, if you look at the DAO.
In the description of work.
In the description of work.
Something else.
Yeah, it's written there should be a workshop in China. Yeah. In November.
And also the workshop in Greece was also really good.
No, you're looking at the older version.
Okay.
Here.
December one. December 7th.
Yes. It's the older version.
What's
And I think it's the version of December wasn't approved by Commission.
oh, which was
Yeah, the way to average a lot of changes.
which version is the latest?
Because the latest, I would say,
I think we are in the long term.
No, yeah, sure.
I'm trying to remember exactly. I think it's sometime around, yes, it's December, it depends on the date. We say around 15th of December, or 10th.
Could you maybe
Do you want that?
could we have it on the wiki or even forward that again?
Yeah. Have you put the DAO in the project website? Have you done that?
Not yet, no.
Not yet.
But the DAO, I don't know if this.
But DAO is not supposed to be public.
It's not public. We can upload it to the wiki.
Yeah.
Do you have the latest one?
Sorry? Well, I don't know if this is the latest.
Could
The
we-
one Yami sent by email in December, I think.
Yeah,
December in December.
He says several.
Can you just tell me the page? What's the page number? Let me have a look.
Oh.
I'll know what's here. What's
The page count.
Yeah, the page count. Page number. Where do you see the additional information? If you look at page 11,
Yes.
page 11, you'll see the year 1. The first meeting is
But 11 of which part of this though? Because there are several numbers.
Description of work.
yeah, the top, yes. I believe it's let me see.
Yeah, that's the limestone.
Right, I think you're looking at the wrong place.
And we are looking at the description of the work package.
Ah, right. That explains it. Yes. The description of work package was done before the negotiation meeting, I think. And there was some, if you remember, the panels had
Yeah.
too many meetings. And so they asked us to reduce to 5 instead of 8 or 6, I don't remember exactly. And so in year 1, we've now decided to.
Do you have the latest one?
Could you possibly share the
Yeah,
latest
okay.
version so we are
you got the connection link?
No.
Yeah, I'll put it on the
You just send it back.
So we have it.
You should have it. I don't know.
We bring them to know which one.
Right, okay.
We will get to that.
The server from the website to see.
Yes, the server is
Okay.
You mean the website of the show?
Yes.
It will be hosted in our website.
Because now I'm based in Shanghai, so I don't know this
Okay. Yes, can we just have a look at the screen? And you'll see that this is what's revised according to the comments made by panelists at the negotiation meeting. And originally we had 4 meetings a year, or 3 meetings a year. And then we said it was too long. So we reduced to 2 meetings in year 1 and 3 meetings in year 2. So the meeting, the first one is in Tianjin, the next meeting is in Spain, in Work Package 3, right?
Yes, but if you move to the one package, then there is a different.
And then year 2, you see Work Package 4, there's only 1 meeting in Bulgaria, and that is a conference, not just a meeting.
Yeah, but the work package 5.
And the Work Package 5 would be
That's good. But I just look at it because
so, okay, I beg your pardon, looks like you're right. So we do have these Work Package 5 meetings. So it looks like 1 work package, 1 meeting. Yeah. So when in Work Package 5, you go to Norway, have a meeting. And then finally you will come back to Tianjin to do the conclusive work, the meeting.
yeah, but my point is that if you move to the work package descriptions,
Yeah.
then it says something else.
Something else.
Yeah.
Work Package 5.
Because that's the DAO I got from your secretary, Michelle Sana, when we signed the contract.
Okay.
Maria Sega.
Maria, yes, Maria. Okay. And the
That's the December 7th version of DAO. That's the one we are looking at.
okay, yes, that is the same. Yes, that is the new latest one, the new one.
Yeah, but if you move to the work package 5 description.
Okay, let's move to Work Package 5 description.